What's a function? A function is a relationship between two variables. One is called independent variable, one is called dependent variable. I don't want to complicate the matter too much there. But to be a function, there's one criteria you have to satisfy, and that is for any let's call it x and y, the two variables here. X is the independent, y is the dependent. So y is a function of x. For any x value, there is one and only one y value. So here's an example. Y equals 6x minus 7. That is a function. Y is a function of x. As I said before, x is known as the independent variable. And y is known as the dependent variable. The value of y depends on what you give me for a value for x. For every x value, that has to be one and only one y value. Now, if you graph that, if we graph y equals 6x minus 7, what does the graph look like? Well, that's a straight line with the slope of 6, y-intercept of negative 7, isn't it? It will look something like this. So this is the x-axis. This is the y-axis. Every x value has only one y value. Pick any x value, like this one, and go, what's the y value for that? Well, let's see what the y value for that one is. Here's the x value. Let's see what the y value for that. Only one. Right there. Whatever that number is. You pick any value for x, you're going to find only one y value for it. Actually, one of the ways to see if you have a function or not, anyone remember? There's a test. Has a name. Anyone knows what that name is called? What is it? It's called the vertical line test. You draw lines going up and down. If any of the lines intersect the graph at more than one point, it's not a function. So when I graph this one and I draw a vertical line test, none of these lines will intersect the graph. Let's go back to that one. So this is my function. And let's do vertical line test. Draw lines up and down and see if any of these lines intersect the graph at more than one spot. Nope. Nope. Only one spot. Nope. Nope. One spot. One spot. One spot. They only intersect the graph at one single point. That means every x value has only one y value. That's one of the ways to see if you have a function or not. One of the ways we test, called the vertical line test. If I have y equals x squared plus 1, and I graph that, that's also a function, because if you graph it, you will see it looks something like this. It is a parabola, has y-intercept of 1. It looks like this. That's x squared plus 1. Do a vertical line test. Draw lines parallel to the y-axis, going up and down. Nope, 1 point. 1 point. 1 point. 1 point. 1 point. So what is that vertical line? It says this x value has only one y value, that's this one. This x value has only one y value, that's this one. This x value has only one y value, that's this one. This x value has one y value. This x value has one y value. This x value has only one y value. This x value has 1. Both of these are functions. So this is a function. And also this one is a function. So what's not a function? Let me draw one that's not a function so you get to see it. How about x equals y squared minus 1? Again, to graph that, here x is your dependent variable, y is your independent variable. The value of x depends on y. So if you want to graph that, you need to make a table and you need to select values for y and find the x value. We like to write x first and y second. So let me pick a value of -2 for y, then -1, then 0, then 1, then 2. Notice I'm selecting, I'm choosing the y value. That's your independent variable now. When x is -2 and you square it, what's -2 squared? 4. 4 minus 1? 3. When x is -1, -1 squared is what? 1 minus 1, that's a 0. When x is 0, square is 0 minus 1, -1. When x is 1, 1 squared is 1 minus 1, 0. When x is 2, 2 squared is 4. 4 minus 1 is 3. And if I graph that one, (3 and -2), that's right here. 0 and -1, that's right here. -1 and 0, that's right here. 0 and 1, that's right here. 3 and 2, that's right there. Notice the graph looks like this. This is x, and this is y. The vertical line tested, is this a function? Let's do a vertical line. I'll do this one. intersect the graph at more than one point, not a function. Why? Because this x value, the 3, happens to have what? Two y values. It has the +2 and the -2. Let's look at 3 here. When x is 3, how many y values do you have for it? So this x value has two y values, 3 and -2, 3 and 2. Every one of these points have two y value except this one. Once one of them has two y value, it's not a function. Now, let's take a shape here, any shape. Still writing? Anyone? Everyone's good? Okay. Let's say I have this box here. And I know the length of this box. The length is 2 units more than the width. I want you to write the perimeter, express the perimeter, or the area, whatever you want to. Let's do the area. Express the area as a function of x. Area, A. I can use A for the area. Well, first let me go back to this. You have a rectangular shape. This is the width, that's the length. I don't know the dimension, so let me call the width x. I could have called the length x, doesn't really matter. If I call the width x, what is the length then? Nope, 2 more. So what does 2 more means? X plus 2. If it was twice that, that'll be 2x. And what's the area? Area is always what? For this shape is length times width. So they want us to write the area as a function of x. I can say the area, I'm going to leave a space there intentionally, is the length, which is x plus 2 times x. But to write that as a function of x, you're going to say the area as a function of x. That's what that notation means. It says the variable I'm using on the right side is the x variable. So the area as a function of x is equal, if you distribute that, you'll have what? X squared plus 2x. You tell me what x is, I'll tell you what the area. Tell me what the width is, I can tell you what the area. So if you came and you said, well, I want you to calculate the area when the width is 5. Well, when the width is 5, this will be what? According to this equation, 5 squared plus 2 times 5. What's 5 squared? 25. What's 2 times 5? 10, that's what? 35 inches squared. The area is all in square units. Let's see if what we did is correct. So when you let x be 5, that's what this one says. X is 5. That means the width is 5. Well, if the width is 5, what's the length? 7. 2 more than that. What's 7 times 5? Is that 35? Yep. Sure enough. This is a very popular way to write a function, f of x. We use that a lot. So I want to make sure you understand how that works there. So I'm going to make a function up. It doesn't really matter what the function represents. Who cares? But given that f of x equals 7x minus 4. Now, if I said to you, what's f of 0? What are you supposed to do when you see that? What do you think we're supposed to do? What is it? 0. Yep. Replace x with 0. Go ahead, let's replace x with 0. So what are you going to have? 7 times 0 minus the 4, which is what? 0 minus 4, that's a negative 4. What is f of negative 3 means? Replace x with what? With negative 3. So let's plug it in. 7 times a negative 3 minus the 4. 7 times a negative 3 is negative 21 minus the 4, which is negative 25. What's f of w means? Replace x with what? Yep. If you replace x with w, 7 times w minus the 4, 7w minus 4. Whatever I put here, that's what you have to replace x with. Where people always struggle when I put something like this. I got the same problem now. Tell me, what is f of x plus h? I go, huh? All you gotta do is replace x with what? With x plus h. So every time you see x, yank it out. In place of it, put x plus h. 7 times x plus h minus the 4. Oh, I don't know why I put parentheses. There's no parentheses there. So now, can we distribute that 7? 7x plus what? 7h minus the 4. Let's try a different function. It doesn't have to be f. Could be g, could be h. There we go. H of x equals x squared minus 3x. What is h of negative 1? Again, what are we supposed to do when you see that? Replace x with what? Negative 1. Negative 1 squared is 1. Minus 3 times a minus 1, that's what? Positive 3. That gives me a 4. If I say h of, I don't know, t plus 1, so t plus 1, what are we supposed to do? Replace x with t plus 1. Now remember, I got to use the FOIL method here. T plus 1 times t plus 1. And if I do that, that'll be what? T squared plus what? 2t plus the 1. Now let's distribute this. Minus 3 times t minus 3 times 1. Negative 3t minus 3. So you have to FOIL it. It's not square the first and square the last. That's an addition. Now we collect like terms. We'll have what? T squared minus t minus the 2. I think you get the hang of functions, f of x plus h, h of t plus 1. You know what that means.